Hello, this is channel Siri Bytes. In this AWS series, I'm recording the third video. Okay, so in this video, I'm going to explain when I opened a new account, what was the setup that I already had. Okay, in my AWS account, a default VPC was there, and the default VPC is in Ohio region, and it was spread over 3 availability zones. One or more data centers is nothing but availability zone. In that availability zone, I was given a public subnet, subnet 2, subnet 3. Okay, public subnets. All three are public subnets. And for the VPC, the CIDR notation is 192.168.0.0/16. So I'm trying to explain you know, what was the setup and how I modifying it to use it. Okay, so 16 means, for example, there are 4 octets in here. So for the 4 octets, the last 2 octets, 8 and 8, 8 bits and 8 bits. Okay, so if I take a the max number of 11111 for each octet, so and all the ones, so how do I calculate? So 2 to the power of 1, 2 to the power of 0 for the last, um, for the first one, and 2 to the power of 7 for the last. So 1 into 2 to the power of 7, 1 plus 1 into 2 to the power of 6, so for each one there, for coming from the left to right, 2 to the power of 7, 2 to the power of 6, 2 to the power of 5, 2 to the power of 4, 2 to the power of 3, 2 to the power of 2, 2 to the power of 1, and 2 to the power of 0. Okay, so if you add all those, it, it was the number should be 255, and the least value is 000s. So that is going to add one more, which is become 256. So if I show you this formula right here, so this is the formula. So I used a formula to calculate how many for the third octet, how many how many IP addresses will be present. Okay, so 256 addresses will be there. So because we are starting with 0, it ends 0 to 255. Okay, and for the last octet 2, it starts the same thing. If you calculate it, 256 variations, and um, and because we are starting from 0, it ends with 255. Okay, so the first is 192.168.0.0/16, and the last one would be 192.168.0.0, I mean 0.255.255. Okay, so that's what it is. So for the public subnet 1, so the notation was, CADR notation was 192.168.0.0/20. So here, the 20 means, so 8, 16, and next is 16 plus 8 is 24. So I'm talking about the octet. First octet is 8, second octet is 8. So 8 plus 8, 16. Third octet is also 8, 24, right? But they are allowing me from 20. Means you got to, the max number would be 1111. Instead of 8 ones, we're having only 4. Okay, so the max number that is allowed is 2 to the power of 3, plus 2 to the power of 2, plus 2 to the power of 1, plus 2 to the power of 0. Okay, this is the formula that I used. Okay, so 16 variations are allowed. Okay, So because we're starting from 0, you can use 0 to 15. Okay. For the last octet, the same, because it is allowed with 8 bits. So starting from 2 to the power of 7 to 2 to the power of 0 can be used. So 256. Okay. So in here, so the first for the third octet, I can use 0 to 15. Public subnet 1, that was. Okay. So this was the public subnet 1, I explained you, right? So this was done. So for the public subnet 2, okay, so because it ended with 15, the subnet 2 can start from 16, and the same 20. Okay, so in the third octet, the last 4 can be used, right? So the last 4 means, again, it's 16 variations will be there. So if you start at 16, 16 plus 16 is 32, but because we are starting from 16, the variations can be from 16 to 31 in the third octet. Okay, all right. In the so for this is for the public subnet too. But for the third subnet, okay, so CIDR is 192.168.32.0. Because we stopped at 31 here, so it started at 32 and same 20. So the third octet, the last 4 can be used again here. So that is another 16 variations. So I started at 32. 32 plus 16 is 48. So 32, because it's 48, we are starting with 32. It ends at 47. So that's the public subnet 3. Okay. And for all these subnets, route table was assigned. The route table is where the route, the destination traffic, if you want to send the traffic to that destination, where are you trying to send the traffic? Where do you want the traffic to go? Okay, that's what given in the route table. In the route table, the main route table, the destination, if you want to go for anything, anywhere, anywhere. So all the zeros in all the octets followed by 0 is anywhere. Okay, it's public. So for the public, so anywhere the traffic has to go, route it to the internet gateway. That's what we are saying. So in here, for the VPC, the internet gateway attachment is attached, or to that the gateway is attached. Okay, so but we're not seeing that internet gateway attachment in here, but in general, a gateway attachment will be there. For that gateway attachment, the gateway is attached. Okay, so that's the route table, main route table, and main NACL too. Okay, so in the main NACL, inbound and outbound would be inbound rules and outbound rules. Ingress, and in general we say ingress and egress. Okay, so for that, inbound is, in the inbound, the source, the type, the protocol, the port range, all are important. In the same way in the outbound too. Type, the outbound is destination, type, protocol, and port range. In the inbound rules, the source is where the traffic is coming from, what type of traffic it is coming, and what protocol it is using, and what port range you are allowing. That is that has to be there in the inbound rules. In the outbound, where do you want to send the traffic, and what type of traffic you are allowing, what protocol you are using, and what is the port range you are allowing on. That's what will be given in the outbound rules. Okay, so for the network main ACL, so we are allowing anywhere, and in we are allowing from any source, and we are allowing to anywhere. That's what it is. So this network ACL and the route table, main route table, was assigned to public subnet 1, public subnet 2, public subnet 3. Okay? So as simple as that. So now, what did I do after that was the main thing that was in the default VPC. So what I did is I created two subnets, private. That is one. Both of them are private. Why I'm saying they're private? Because I don't want to allow any traffic from the outside, means 000. I don't want to allow that. Okay? Anywhere public, I don't want to allow that. That's why I called both of them as private. So the private, yeah, okay, subnets for, I want to create subnets, okay, I did. But what would be the CIDR notation? So interdomain routing, right? Classless interdomain routing. Okay. So if I have to have a CIDR. So for the private, what did I say? So for the private, I'm saying for the public, I stopped at 47. So I started the private at 48 and gave the same 20. For the third octet, I'm allowing the last 4. So another 16 variations. So 48 plus 16 is 64. So, but I'm starting with 48. So it ends at 63. Okay. But the for the fourth octet, I'm not explaining, but if you can see, it is starting with 0 means, you can assume 200, not assume, you can think about it. It's 16 bits are allowed. Okay. So that's what it is. Okay. So that's what the CADR notation is. That's what I have given for the private subnet 1, and for the private subnet 2, this is what I did, because it stopped at 63. I'm starting at 64, and then the third octet, last 4 is allowed. So another 16 variations. 64 plus 16 is 80. Because I'm starting at 64, I stopped at 79. So 64 to 79. Okay. So what I'm saying, 192.168.64.0/20. The next would be 192.168.65.0/20. Okay. As simple as that. Okay. So that's the explanation of CIDR. And but can the public NACL, main NACL, and the main route table can be assigned to this? Yes, it can. But what's the point? The point is, if you are allowing 000, and if you are naming it as private, it doesn't make sense, right? So what I have to do is, because my requirement was not to allow, so I need to deassociate the main route table and the main NACL to both of these private subnets. And what I have to do, I have to create a private route table and private NACL. So what in that private route table, what I am saying is, okay, please allow the traffic, okay, please allow the traffic only in the VPC, and that too, the target is local only. That's what I'm saying. Okay. And I assign this private route table to private subnet 1 and private subnet 2. Okay. And here, in the same way, I created a NACL, and for that NACL, the inbound and outbound rules and outbound rules, ingress and ingress. So ingress, the same thing. What I'm saying is, please allow only the traffic from this, okay, from this traffic only in the VPC and allow anytime. And in the outbound too, I'm saying please allow only the traffic inside the VPC only, but allow anytime, on any port, on any port range, on any protocol. That's what I'm saying for both. And I associated both the this NACL for both the private subnet 1 and private subnet 2. That's what I did. Okay. So this was the setup that was given to me. So in this, that's what I did. So in this, I have to start doing something, right? So I said, okay, let me create a jump host, where jump host is it's a EC2 instance, it's a elastic compute instance, and it's a cloud instance, and I said that I want to create in public subnet 1. Okay, that's what I did. Okay, but I did create from, I will show you that, but from my management console, I created this. Okay, from my management console, I created this. From the management console, I created this, but I have to connect to it, right? So I have to connect to it too. So I have to connect to it, I have to give a security group. The security group is like a firewall that's acting for that jump host. Means security group is nothing but the rules, ingress and egress rules, okay, that's been applied to that particular instance. Which traffic can be allowed and which traffic cannot be allowed, okay. But this is in public subnet. Public subnet, you allowed anything public, right? 000. But for this, yes, I want some traffic to be only from certain range or certain protocol on or a certain IP address. I can do that by defining those rules in the security. So what I did is, from the console, I created the jump host. Okay, so for that, what I did say is, okay, we can call the jump host as Bastion Host too, the same. So the source, what I did say is, okay, allow from my private address, means my PC, my network, allow from that source port 22 and SSH, okay, allow SSH, and also allow ICMP, means I can ping and see before connecting to SSH. I can ping from my local machine and see is it reachable or not. Okay, so that's what I said. Please, from my private IP, my local private IP, allow the traffic to AWS and connect to jump host. The port is 22, please allow it, and type is SSH, please allow it, and as ICMP, please allow it. That's what I said. And the outbound, so the security group is stateful. That means that once a traffic that is allowed in, so that the same traffic will be allowed out without any key specifications in the ingress that we need to know. But if certain traffic you want to allow outbound, you need to specify that. If it is not in the inbound, But you are thinking that from once I connect to the Bastion host or jump host, I want certain traffic to be allowed out from my system. You need to specify that rule. Okay. But here, whatever you specified in the ingress will be allowed without specifying in the outbound. That you need to. Okay. All right. Let me show you because I think I explained everything in here. So let me show you in my console, and I will show you exactly based on what I explained here. I will show you those details. Okay. All right. So this is my VPC. I renamed it as NL VPC, and so these are the subnets that I showed you before. So 1, 2, 3 was given in the default. I created these private subnets, these two. Okay. So this is the main route table, and this is the private route table I created. This route table is associated with all the public subnets, and this route table with the private subnets. Okay. These are the network ACLs. So this one is associated with public subnets, and this one I created it and associated with private subnets. Okay. So this is the Bastion host I created from the console, management console. So, and I said I gave a security group which I allowed 22 and SSH as well as ICMP. Okay. So that's what I just want to show it to you. That's what I did. So to create this Bastion host, all I used is the free tier. Okay, the free tier AMI, and for the Bastion host, while you are creating it, you need to create while creating this you have to give a AMI, Amazon machine image, the security group, and instance profile, and key pair. Okay. So the key pair from which you are using in PuTTY to connect from local system to the jump host. Okay. So here, because you are connecting from local PC using PuTTY, you need a PPK key pair. Okay. So you cannot use a PEM. Cannot use .pem in PuTTY. Okay. So the PPK and all these are minimal configurations I am trying to explain. But while you're trying to, you know, um, create any kind of EC2 instance, there will be so many, um, based on the requirement, you can, there's so many properties that you can, while creating itself, you can assign. Okay, you can, I mean, I don't want to go through that process right now. This is so, I don't want to show you that process, entire process. So I just want to show you what it's it's pretty much like a series that you can do what I am saying on your own. Okay, all right. So this is what I did. Okay, and you can, there are so many things, the volume you need to give, and where, what kind of volume is that, what you know, you can say that, whether any file systems need to be connected, you can say that, and whether it has to be, you know, set up in any kind of cluster setup, needs to be which it has to be in any cluster setup, you can say that. There's so many things you can do while creating a EC2 instance, but I'm explaining you in a simplified way. Okay, so in the